Okay, let's take a look at linear approximations. I have a graph here that's not on your paper, so if you just pay attention for just a second. The whole idea of this section says that a tangent line at a point, that tangent line is approximately the same value, or has approximately the same value as the function near that point of tangency. So you notice the blue line matches up with the red graph close to that point of tangency. The further you get away from the point of tangency, the further away that the value of the function and the value of the tangent line are. Okay, so that's the whole gist of this here. So a key part of calculus is approximating. The derivative is the slope of the tangent to the curve at a point along the way. Hey, a tangent line is extremely close to the actual curve near this point. Therefore, we can use the tangent line to approximate. Right. To do this, we need point slope form of an equation of a line. You can use slope intercept, y equals mx plus b, but there's an awful lot of chances for mistakes. And the point slope is designed for this situation where you're given a point and the slope, which is exactly what we're going to be given. So we'll be plugging in for x1, y1, and the slope. Right. So number 13, given this function, f of x equals x squared minus x to the fifth plus 3, write the equation of the line tangent. Well, I have a point. I need the slope. The slope is the derivative. So I'm going to start off finding f prime of x. That's 2x minus 5x to the fourth. And now what I want to do is I want to evaluate f prime of 1, because 1 is the x coordinate of that point. So I get 2 times 1 plus 5 times 1 to the fourth. And that comes out to be, that should be a minus. Sorry about that. And I get negative 3. Therefore, my equation is going to be y minus the y coordinate equals the slope times x minus the x coordinate. Use this equation to approximate f of 1.1. So now I'm just going to go to my equation, and I'm going to let x equal 1.1. So I get y minus 3 equals negative 3 times 1.1 minus 1. Do the math in the parentheses. 1.1 take away 1 is 0.1. Multiply that by negative 3, I get negative 0.3. Add 3 to both sides, I get y equals 2.7. So f of 1.1 equals 2.7. We now plug this into a calculator just to see the difference. So you can see they are different, but they're pretty close to one another. Okay. Number 14, given the curve, y squared plus 2xy minus 3x equals 5, show that dy dx equals this. And again, notice we have a product, so be very careful. We're going to need that product rule. Write the equation and then use the equation to approximate the value of the curve. So let's derive using implicit differentiation. So I get 2y dy dx plus 2 times. And again, I use the constant on the outside and then I derive the product. So it's 1 times y plus dy dx times x minus the derivative of 3x equals the derivative of 5. Clean this up. And at this point, we are good to go ahead and finish solving. If you need to do a few more steps, that's fine. I'm going to move the 3 to the right side, so that becomes plus. The 2y goes negative. And then we pull out the common factor of dy dx, and that leaves me 2y plus 2x. That gets divided. So now I want the slope, dy dx, at the point 1, 2. So plug in 2 for y and 1 for x. Equals 2. And I get negative 1/6. And now we go ahead and we write our equation. So y minus 2 equals the slope times x minus 1. And now we're going to plug in 0.9. So I get y minus 2 equals negative 1/6 times 0.9 minus 1. That gives me negative 0.1, which, to be honest, I think in this case, I'm going to go ahead and write that as negative 1/10. So negative 1/6 times negative 1/10 is positive 1/60. Now we add 2 to that, and that gives us 2 and 1/60, which is 121 over 60. And again, if you want the decimal version, you get 2.016 if you truncate, or 2.017 if you round up. Either is good. Number 15, let f be the function defined by this. This wasn't originally a multiple choice question, so we should just say find an equation of the line tangent to the graph at the point where x equals 2. So that means I need, first of all, I need a point, not just an x, so that's going to be the point, comma 2, comma something, and then I need the slope. Well, the slope we know is f prime of 2, so we'll find that in just a minute. The point, the y-coordinate of the point is just whatever f of 2 is. So let's start off by finding f of 2. So I get 2 times 2 cubed minus 2 squared plus 5 times 2 minus 1. 2 cubed is 8 times 2 is 16 minus 4 plus 10 minus 1. And we get 21. So our point is the point 221. Now let's find f prime of x. That would be 6x squared minus 2x plus 5. F prime of 2. 6 times 2 squared minus 2 times 2 plus 5. It's 4 times 2 is, or sorry, 2 squared is 4 times 6 is 24. Minus 4 is 20. Plus 5 is 25. Y minus y1 equals m. X minus x1. Then we do the same thing. I mean, this is exactly the same. It's just an exponential function. So I have x equals 0. So my point is going to be 0, comma, f of 0. Let's go ahead and do that. So y, whenever x equals 0, is 2 times e to the negative 3 times 0. Negative 3 times 0 is 0. E to the 0 is 1 times 2 is 2. So I get 0, 2. And then my slope, so y prime, or dy dx, is going to be 2e to the negative 3x, because the derivative of e is e, times the derivative of that function, which is negative 3. And y prime, when x is 0, is negative 6e to the negative 3 times 0, and that comes out to be negative 6. That's the slope, that's the point. So I get y minus 2 equals negative 6, x minus 0. And again, you do not have to simplify. If you want to, you may. And that's it. You should be good enough to go ahead and work on assignment, the assignment talking about linear approximations, tangent line equations, and interpretations.